Hello, everyone. Thanks for coming. It's great to see you here. It's great to be at this event. I'm going to talk to you today about threat modeling a batch job system. I have a lot of slides, and this talk is based on me building a batch job and thinking I'm just going to show people how to run this batch job in their account to run some security scanning tools, and then it turned into something much bigger. Okay, how do you secure that? And so on and so forth. So I'm going to get through as much of these slides as I can, and I also have links in all of the notes, and the links are friend links. So a lot of my pages on my blog have a paywall. I'm sorry. I have a talk explaining why I have that way. But there's a lot of friend links in this slide deck where you can just go to it for free. So I'll post it afterwards. So if you don't catch something, don't worry. I'll post it on social media, and you can go check it out. So why did I start writing this batch job process? Well, first of all, I'm a pen tester, and I use it. I use it to run my scanning tools, my reporting, and so on. But also, I do security consulting through a company called IANS Research. And a lot of people ask me questions, and I don't really like the questions because I don't think they're the right questions. They'll ask me things like, what tools should I buy to solve all my security problems? And they'll ask me, can you give me a reference architecture? Or can you give me a list of steps that I can follow? And by following these steps, I'm secure now. Those steps, by the way, are called compliance. How many companies do you know that have followed the steps and still have a data breach? So there's a little bit more to it, and it's kind of aligned with the keynote this morning. I think security is not a checklist. It's an architecture. And in order to write the proper or build the proper architecture, you need to know what you're building, and you need to know what the attacks are. In other words, it's based on a threat model. So when I was in college, I actually started out as an art major and a business major. And so these are some of my drawings. I don't do any of this anymore, any drawing or painting. But it's really interesting when you're painting or drawing something, you have to look at it very closely. You have to look at the shadows, the light, how it reflects off the object, the shape of the object, all these different things. And so when you're building security architecture, I think it's like art. You have to understand how to build a good architecture, first of all, to do whatever your application needs to do. And then you need to think about all the ways that it can be attacked. And you need to use those architectural components to build something secure that will defend against those attacks. So how do we learn how to build great architectures? There are many resources out there. This is Grace Hopper, and I just noticed that she is the first picture out there outside this building right here. Her talk was recently released by the NSA, and this is just one example where you can go listen to someone who's built architectures, and it's amazing how many of the things that she talks about are still relevant today. The other one I like, every year I listen to Werner Vogel's keynote at AWS reInvent, and the one this last year was especially great. He talked about all sorts of architectural principles. Those principles change over time, they evolve, so that's also a great thing. I'd say go watch all of his keynotes because they're so great. So let's talk about batch jobs now, because this is what I started building. And what is a batch job? A batch job is some software code that takes some inputs, it processes some data, and it produces some outputs. So really, a batch job could be almost anything that processes data. You can also take jobs and you can string them together. So you can have one job that feeds, take some inputs, get some outputs, and then you take those outputs and you feed them into the next batch job. And there are reasons for doing that because you have different processes and different things you need to accomplish. And so you can create all these jobs and chain them together. There are a lot of things that use batch jobs. So I used to do back office processing for a bank. And when you work in a financial institution, you have this thing called end of day, and it runs all these batch jobs, usually batch jobs, and it has to reconcile all the systems before the next day. So that's where I used batch jobs heavily. Also reporting systems, I write my pen test reports with batch jobs. Image processing is a good one. Tax reporting, I've worked on tax reporting systems. I also have started writing deployment jobs. And the other one that I started with was the security scans, right? I wanted to show how to do a security scan in a batch job and how these batch jobs can be useful for security processes. So there's some general rules for batch jobs. I'll let you read this over later, but basically, you have a single process. You don't want to have this monolithic huge thing. You usually have a single thing that you're trying to accomplish with the batch job, some inputs and some outputs. And then you want to make sure that batch job is rerunnable. It's a very key point. If you have, especially like a financial transaction, you cannot have that transaction happen twice or too many times or not at all. If it starts over, you gotta make sure you don't have duplicate processing. You can speed batch jobs up with parallel processing, multi-level processing, and all these other things. Now, when I wrote this system, one of the key points is I want to use MFA, and I want to enforce MFA every time I run a batch job. And why do I do that? Because I do penetration testing, and I analyze people's accounts. As part of the pen test, I also sort of do a security assessment where I look for all the misconfigurations in the account. The customer gives me a role. I don't want to be the one to have my role compromised that I'm using in the customer's account. And there's things you can do like external IDs and so on and so forth, but I really want to enforce MFA, and I tell the customer, put a condition in that role and say it must be used with MFA to assume that role. And so I've written tons of posts here, which you can go read, on using MFA and trying to accomplish this and create a batch job that requires MFA. And I have something that pretty much works right now. And I tried things like doing this on a Lambda function. I looked at AWS batch. I looked at, what I ended up with was EC2 instance on a container because I had some problems with the Lambda function and assuming the role with MFA, it just couldn't get working. Maybe it works now. And I also explained how to create roles programmatically, whether you should use an YubiKey or not, and I'll talk about that in a minute. But I have a lot of posts on sort of going through this process. And what I ended up with is I'm storing the credentials, those keys you may have heard about in a couple talks now. Those AWS access keys are so dangerous. You can generate those keys programmatically, put them in Secrets Manager, never give them to a developer, and use MFA. So when the developer starts a job, they use MFA on the CLI on the command line to start that job. They never have the credentials to steal. It's a one-time use code. You make sure that you have to use it every time you run a job. So if you have these really critical, sensitive jobs, you don't have the risk of those stolen credentials. They're encrypted with Secrets Manager. You can encrypt them with a user-specific key or user-specific secret. So lots of blog posts on that topic. But that was one of the key points of this whole thing. So here are some examples of things that I've done with batch jobs in the past and some things to think through about how they might be compromised. I converted a COBOL system. It was a retail sales tax system from COBOL to SQL. So that's kind of in the news right now, right? And it was off by $300,000 a month. And I went in and helped the team fix it and make sure that there were no more discrepancies. So what we did is we created batch jobs for different steps of the process. We gave them letters. We had logic in the system. A has to come before B, or A has to come before B, and so on and so forth. We made sure there was no duplicate processing. We had tracked the error messages really well, and also implemented, if you are familiar with the producer-consumer queue, so while one record is waiting for a response in the network, we send it to the other system. You could have some other process doing something else. So that's one example. Another one was dividend processing, where there was a huge list of records that would, processed all the dividends to pay people their dividends each night in an investment bank, and turned that into a batch job process, and also it was already a batch job process, but batches of records that were processed in parallel to speed it up, and also fixing some reconciliation problems. So one thing I don't talk a lot about here, but if you have these processes, one of the attacks is to make sure that you don't have something that can get inserted that can cause the reconciliation to fail or be off, and someone's sniping a little bit of money on the side. So you have to make sure that your transactions are correct and you have the proper rollback strategy or fixing a forward strategy in your batch jobs. Then I started building my own batch job to show you, oh, look, you can run this thing in a batch job. But what I realized is I could tell you how to run this batch job to run your security tool, but if that's not secure, you may be attacked and compromised through my batch job, so I have to fix that. And that's when the whole thing just blew up and went crazy. How do I tell you how to fix that? And I started exploring using CloudFormation in a batch job, so I have a whole bunch of code out there on how I tried to do that. And I came up with this concept of micro-templates. Well, I've been using micro-templates since I started using CloudFormation, so this is just a tip. I had a guy working for me, super smart, came in, just amazingly smart guy, off the charts, 99% on the intelligence test, but he hated CloudFormation. So I said, well, stop building these monolithic stacks. Put each resource in its own stack. And there are some benefits to a monolithic stack and letting AWS control the parallel processing and dependencies. But if you're having problems and you pull those out and you manage that yourself, now you can independently run each resource. And if you have a problem, you can redeploy that one resource and fix that one problem instead of waiting for the whole thing to run and having all these weird rollback issues. So if you're having problems, this is my approach. This is how I like to use CloudFormation. So I wrote this, I have a lot of code going towards this deployment system. It's not quite done yet, but there's a lot of things you can use if you're trying to do CloudFormation deployments or any kind of deployment, really. You can take a look at those concepts. And then there's a job that I started with, I just wanted to show people how to run a security scanning tool within a batch job. And one of the issues I have with Prowler is that if it fails and you're running all the scans, you have to start from the beginning. So if I'm doing a huge pen test on or a bunch of, very large account, I start from the beginning. What if the session times out? What if the customer has a limit on the session that I can't control? So I basically made Prowler rerunnable. I have a couple of solutions up here. One is not as good as the other, but it was a quick and dirty way to get it done. So now that you kind of have this concept of batch jobs, let's talk about the threat modeling. So you always hear this thing, if you're familiar with security, and if you haven't, is think like an attacker, right? And so what does that mean exactly? So I wrote this blog post for my mom, because she's like, I have no idea what you do. I don't understand it. I don't even think she read the blog post. But I'm a penetration tester. I test your systems. I think like an attacker. I go in and simulate what an attacker will do, and I try to break into your systems, and what do? I take every input I can find, and within the time that I have, and I try to throw bad things at it, and I try to manipulate the system and bend it to my will. I want to get your data. I want to find any vulnerabilities. I want to get it to do what I want to do, and I'm trying to use the inputs on a form, for example. If I'm working with an API under the hood, I'm submitting things to the requests, the API requests. If I'm in a cloud, I'm looking for all your misconfigurations. I might be looking for ports on your network that are open. I'm going to try to connect to them. So any way that I can submit data to your system is a potential problem. So risk is really about how many chances are you giving an attacker. So what do I have to work with as an attacker? I have all these inputs. Whatever inputs you give me, I can try to manipulate, right? And so one way to reduce your risk is to reduce the number of inputs, and the other thing you need to do is protect those inputs appropriately. Your attack vectors are all the ways that it can attack the system. So what programming languages do you use, how many cloud environments do you use, all the different ways, any sort of technology, you're using Java, are you using Rust or what have you, they all have different capabilities and different ways I can attack them. And the attack paths are, how are the systems connected? So a lot of times an attacker will get in, they'll attack one system, they'll leverage that system to get to another system. I'm going to show you an example of that. And so how many attack paths do you have? And I actually wrote a tool that in AWS will look at all your networking and tell you how many systems can connect to other systems. And the easiest way to reduce your risk is go in and reduce the number of connections. And when you open all your ports to all your ports, you have exponential potential attack paths, whereas if you reduce those down, you significantly reduce, depending on what's running and exposed on those ports, how many things can connect to how many other things. Often an attacker will get on your system and they'll run their own software that they can connect to. So you have a C2 channel, right? And if you have closed a lot of ports, you're limiting their ability. There's tricky things they can do, reverse proxies, whatever, but you're limiting their chances to run those type of things. If you want to know about a lot of different types of attacks, you can look at something like Miner Attack, and they have one for cloud specifically. I think they have one for Kubernetes potentially, and they'll show you here are all the attacks that are possible on your systems, and it can be overwhelming. What I like to do is I like to go look at the attacks that are happening now. What is actually happening to people? How are they getting breached? And talk to people and read the reports of what's going on and learn from that. And this can happen to anyone. So when you see someone get breached, it's not like, oh, they didn't know what they were doing. No, it's really hard. But what we can do is if they tell us how they got breached, we can think, oh, well, is our system susceptible to that breach and how can we fix it? And so I think when people tell you what happened to them in a breach, it's really a gift. It's not, you shouldn't be berating them because they had a breach. We should be saying thank you for telling us how that happened so we can go see if our systems are susceptible or not. And so this is one that my friend George was involved with. He was the CISO at Sumo Logic, and he is part of this great article that tells you exactly how they had a breach and what they did. Super interesting. And one of the things was they were running a tool called Truffle Hog, and guess what? Their AWS secrets were stolen, right? Their keys. So really, the whole thing I just described to you with MFA, I think would have prevented that breach. Because even if the attackers got the keys, they wouldn't have the MFA to get the token to submit. And the other thing is the way I'm doing it, those keys are never in GitHub. They're actually in Secrets Manager. And I do connect to GitHub. I put my GitHub secrets for my jobs inside Secrets Manager, retrieve them, run jobs. So effectively, I'm adding MFA to do things like what GitHub Actions are doing. I have a problem with how they work. You can actually simulate that and do things on GitHub without exposing those credentials. So I have some things here after every one of these breaches that explains in more detail, but I'll let you read that later due to time. So the next one is Circle CI. So in this case, you have a developer working on their system. They have access to do something very sensitive in production, and the attacker got on their system through their music software. So you're running your software, you're listening to cool music, and there's a vulnerability, and boom, you got breached. So what happened is attackers got on the developer system. They were using MFA. They got breached because the attacker stole the session. So for all the people out there that are using OIDC or something else, and they're like, yeah, we have no more credentials, you still have sessions. And if the attacker can get in and get your session tokens and whatever you're doing with that session, you could be compromised that way. And they also got into the developer's machine, and they got into memory, and they stole secrets there. So they're doing a lot of the good things, right? But what happened? Well, first of all, if you run whatever that process was, that production process, in a batch job instead of on the developer's machine, in a private network, you don't have the attackers getting into the developer's machine and getting direct access to those things in memory. And that session that you're using is not if it's a long-running session, you have a problem. But if you have to trigger the batch job with MFA every time, it's going to trigger the batch job. You got a one-time use token. Yeah, maybe there's a way they could get that, but it's going to be much harder, right? And so I go through here some of the things: short sessions, things in memory. The other thing we want to do is, I think more developers should learn the details of network security. I really want you to learn this because it's very important. It's one of the most important ways you can stop breaches. One time I'm working on my laptop, and all of a sudden I see this pop up. I run a host-based firewall, and I run a network-based firewall, and it says, hey, your system's trying to connect to Alibaba, and it says it's Google Helper. And I'm like, I don't think so. So, you run those things on your system, you learn how to monitor your network, you're going to be able to stop these attacks. I have a bunch of blog posts on here. Learn packet sniffing, learn network traffic, learn how those packets work, learn how DNS exfiltration works, and you can take something and stick it in a DNS query and exfiltrate it, because all your systems need DNS, right? It's always DNS. So you want to understand how that all works. Next is a SolarWinds breach. So this is super interesting. I was talking to a security vendor, and I said, how could someone perform a supply chain attack on your network appliance? And he said, well, you can't, really, because when it comes down from our systems, there's a checksum, and it makes sure that the checksum matches what we built. And there's no way that could happen. If it did, then everything's broken. And that's essentially what happened with SolarWinds. So there's this network monitoring software, right? And they're building the software, and then they're shipping updates to customers over the network. And while the process was building, and this is something that's not in my blogs, but I provided the links I learned later. So while the process is building, the attackers swapped out the executable. So the checksum that was produced at the end was the checksum of the attacker's system. So when the checksum, this software goes out, and the client says, oh yeah, that's the right checksum, it's actually malware. So it's super tricky. So how do we protect against that? That's just crazy. Well, if you were running that process in a secure batch job environment where someone had to use MFA to get to that system, and you secure your source control system so that no one can insert source control in the process, and if there's no external sort of network connections, no way an attacker can get into that batch job that's building that software, how are they going to swap out that software? They can't get in through the network, and that's why network security is so important. And I have some other things here up there that will help you. So then there's my alma mater, Capital One. Very smart people working there. And this can happen to anyone. But the thing here was you have this system that was running a WAF. I should actually work with some of these people to implement some of these things. And the attacker got onto the WAF. The WAF had a rule that gave it permissions to access all the S3 buckets. Why all the S3 buckets? They said it was a misconfiguration, maybe it wasn't, but that's a problem. So you have this externally facing system, has permission to access the buckets. The attacker gets on, not even on the system, but leverages that system through a SSRF attack to get into all those buckets, right? So I use a lot of S3 buckets in my batch job processing. So if someone can get into my batch job, they could use that batch job to get into those S3 buckets potentially. Same type of thing, SSRF. So we don't want that happening. So one thing you can do is you can't necessarily prevent every single breach and attack, but one thing you can do, and I leverage heavily, is to segregate things and separation of duties. So you can make, different environments for different data. You can do different ways of segregating your data, your repositories, and I have lots of blog posts on that. But in this case, one thing that actually helped Capital One, because even though it was bad, it could have been worse, was some of the applications were using application-specific encryption keys where only that application's role could get to the key to decrypt the data. So even though the attacker got to the S3 bucket, they couldn't decrypt the data and use it. So I have a lot of blog posts on encryption and using specific permissions to help you create that sort of segmentation or segregation with different resources. So yeah, separate. And then also the other thing is monitor for exfiltration. So I do talk a little bit about logging in my blog post. So I talk about how you set up CloudTrail logs and things. But if you see a large data movement on your systems, you may want to look into it. And then in fact, someone said at Capital One they did, but they didn't recognize it as a threat when it was happening. So the other thing is you're trying to protect against phishing attacks and so on, and you have something like the Octopus issue with Okta. And really, this was phishing of Okta customers. It wasn't like Okta did something wrong necessarily. But one of the things with the Okta phishing attacks is it's using the OAuth code flow. So you have some MFA solutions that you're using the command line, and Microsoft was the first one to do this, and then you have to go out to a browser and enter a code and come back. I don't actually like that solution. The OAuth code flow is often breached, and I just wrote a blog post about all the things that I try to attack when you have OAuth, and there's a lot of URLs that can be directed around. You may have an open redirect. You may attack that. So I don't particularly want to use that solution within my batch jobs, although if I ever had some sort of web interface, maybe you would have something like that. But that's a risk. And the other thing is, the interesting thing on this is I believe Twilio was susceptible to this attack. Twilio is a system that sends SMS codes around, or it sends SMS messages around, and some of those are those messages you get when you're signing into a system and you have the code that comes back to you and you have to enter it in your system. So in this case, the Twilio engineers had access to the SMS messages that were going back and forth, and those messages were breached, or their accounts were breached, and then the attacker had the ability to read those SMS codes as they're going through the system. So that's another thing you want to think about, like, And well, how do you protect about this? In a web browser, you want to use a YubiKey. This is right now the best solution. So there is a tool called Nginx, and it actually works like a proxy. So it will proxy the actual website you're logging. Let's say you're logging to AWS, Amazon.com. It will proxy that to you. You'll see the legitimate, literal website, and you'll log into it, and you'll think you're on that website, and then they'll proxy over to the AWS website, log you in, and come back. In the middle is where they're stealing your code, your credentials, your code, you're entering your MFA code. So they're stealing everything. The person who wrote that said, right now we don't have a way to get a YubiKey. So a YubiKey is using a different mechanism, and that will protect you from the tools like Nginx. They're very dangerous. And it's going to be better than sending codes around. But when you're in the AWS CLI, I really don't like having to go out to a browser, a separate system. You've got all those network issues I was telling you about. You've got all the potential browser attacks, 0 days. You're just a greater attack surface. So I still like using the codes in the AWS CLI, and all my articles show you how to do that. They show you how to get in there and enter that code on the command line, how to configure it, and even automate it. So take a look at that. The other thing I've seen is people using a YubiKey, so they'll generate code from a YubiKey on their local system, and they'll use that. The problem with that I don't really like is that you have to install the YubiKey CLI on your system, and that's also another point of attack because that CLI is used to manage your YubiKey. You log in as admin, you're making changes to your YubiKey. I run that software on a separate laptop. I don't run it on the laptop where I'm working every day and I'm doing my work. Or you could even have it under a separate login if you only have one laptop. So that's the problem I have there. There's no perfect solution, but this is just my take right now on the best solution. So let's talk about creating your security controls. You know about all these attacks, you want to create these controls, and one of the pitfalls I see is people, they want to build a security control, and they build this one control, big wall, and they're like, okay, we're done. But is your wall, your control, is that really going to stop the attacker, or is that just a speed bump? Because ultimately, if the attacker is persistent enough, they're going to get over that one security control. So what you really want to do is think about, okay, how am I going to stop them with, what is my approach going to be that's not just going to be a speed bump, but it's actually going to stop them or help me tell if they're there more quickly. I also see some security logic flaws. One of them is this, like the checklist, right? We went through compliance, we did all the things, therefore we're secure. Well, take encryption, for example. I actually just saw an article on Google's AI product where they had encryption, but they actually put the key somehow in their solution. So what the bug bounty researcher did is that you put the key in the solution, so I just used the key to do the decryption or whatever the thing was. So if you have encryption, but you don't protect that key, that's an example of, yeah, I checked the box, I have encryption, so I'm good, right? But it's not actually working because you have a problem. The other thing is you may have gaps, so you have this really secure solution, but you have this other gap over here that lets the attacker by. And so you have things like that. The other one is like, this thing is a problem, let's get rid of it. We have a problem with AWS access keys, so let's just get rid of them. Well, what are you replacing it with? What you replace it with may have the same problems or similar problems or different problems. So instead of replacing it, let's fix the problems. What we really want to do is we want to have defense in depth. So I've showed you how in my batch job system I have MFA. I'm using encryption to protect the data. I've got a secure isolated network for my batch jobs. I'm monitoring. So there's a whole bunch of things there that I'm using. It's kind of like when you go to the airport. There's not just one checkpoint. There's like 3 different places or more sometimes, depending on what you're doing. But when you add all these checkpoints, you have complexity. And in the words of Bruce Schneier, who's a famous cryptographer, when you have more complexity is the enemy of security, and I do agree with that. You start to have all these things you've got to manage and think about. But on the other hand, Einstein says, supposedly, you want things to be as simple as possible, but not too simple. So you say, I don't want to lock my door. It's a pain to carry this key around. I'm just going to leave my door open. Well, that's simple. Not smart in my neighborhood where people just go try doors and try to get in. So you got to balance these two, and I'm always trying to simplify my design. And that's one of the reasons I haven't released, among other reasons, my recent code, because I'm like, it's too complicated. I added some features, and I'm trying to simplify it. And as security professionals, we want to think about our architecture and how to simplify it. And if I had more time, I'd write a shorter presentation, or shorter letter. This is the word of Mark Twain, and I think that's true. Every line of code is a potential bug, so can we reduce the lines of code in our application and the things that may be susceptible to errors? For example, you copied the same function in 3 places, and you need to change it, and you forget to change one of the places. That's just one example. You also have, I get this on pen tests all the time, you have all these third-party applications people are connecting to, and guess what? As a pen tester, out of scope. You're depending on their security for your security. And what if they're breached? And we have all these examples, polyfill.io, colors.js, XC Radichel, all these different things have been breached. So I think the colors and faker, I think it actually affected some AWS components that you use on the command line. So you want to think about those third-party components. And one of the ways you can reduce your code is through abstraction. So in cybersecurity, I like to use this term abstraction, and other people use it in different ways. What I'm talking about comes from code design patterns, where you have an abstract class, and you can put your common functionality in that abstract class. You can put your common interfaces, and then the things below it can implement those interfaces in a different way. And you can even put the code that is common across all those components in the abstract class. So you have that code in one place. So think about patterns like that. More details on my blog, and I think about the abstract factory pattern, which if you program Java for a long time, you might know this. It's used to generate new objects. I kind of have a batch job factory where I create new batch jobs securely. And then I have a whole bunch of lists of security ideas here, and I'm running out of time, so this is your homework. I kind of knew this was going to happen, but I have some ideas and some new things I'm working on here, and some things I've written about. I've got lots of blog posts, DNS security, encryption. So go through and take a look at that. Secure code, lots of blog posts up there. I've got some code online, but it's a little old. I haven't had time to put the new code out, but you can go look at that in conjunction with my blog posts. And these are some of the revisions I wanted to just quickly talk to you about. I'm not going to go through this, but read them. But one of the things is really separating repositories. Why do you have to give people access to all your code? So I was thinking about how I could release my job factory code, but not give you that access to change it. But you can create your own jobs. You can have your own repositories and use them with that. And then you have all these third-party repositories, and you don't want to copy each third-party repository over and over again into the same, into every batch job. So I have this whole way of managing that I'm working out, and a bunch of other things. That's one of the biggest changes. Running jobs in parallel, and running jobs in multiple accounts with different configurations. There's a lot of things I've thought through up here. So if you're interested in batch jobs, I have a ton of information out there. And I have a bunch of posts on pen testing as well. So I'll probably do more with this idea of running batch jobs for security when I have time. So that's my talk, and I will publish this online. I'm at Teri Radichel, or Teri Radichel, my name, on LinkedIn, on X. If you don't like X, I'm on Blue Sky, I'm on Mastodon. They're all at the bottom of all my blog posts, on my LinkedIn profile. I have a mailing list on my blog. If you sign up for that, you'll get my new posts. And there's some stuff about me, and I have a cute dog. So that's my talk.